Okay, we're going to talk about basic probability in this video. Remember a couple of terms that we have. We have mutually exclusive. Sometimes I'm going to put this one on here, mutually exclusive or disjoint. They can't both happen. If one happens, the other one cannot. Okay, then there's independent. If one happens, it doesn't change the chance for another. Okay, so independent and mutually exclusive. If one happens, mutually exclusive, and the other one can't, the probability goes to zero. Then they are mutually exclusive. But mutually exclusive are not independent. Those two things are totally different. You have to remember, independent is something entirely different. Excuse me, sorry about that. Okay, so number 6, a fair coin is to be flipped 5 times. First 4 flips land heads up. What's the probability of heads on the next flip? Well, that would be 50% because they're independent, and that idea needs to come through in there. All right. You will have some multiple choice probability. Hopefully some are that easy on the AP exam. Do the ones you can. Take your best guess on another. Now, these next ones, I call them the 1, 2, 3 questions. They're probably the least favorite of many students on here. So this one, we got a little work to do. You can have multiple things. Play the process of elimination. Like the answers, it says it's 1 only, 1 and 2 only, 1 and 3 only, 2 and 3 only, 1, 2, and 3. So you have to know which ones of these are correct. It says an experiment has 3 mutually exclusive outcomes. Okay, so you have to know what mutually exclusive means. A, B, and C, meaning they're mutually exclusive. They can't happen at the same time. A is 12%, B is 61, and C is 27. So first, you might say, well, okay, does that add up to 100%? 12 plus 61, that would be 73 plus 27. Sure enough, those add up to 100%. So if they're mutually exclusive, if you were to draw a Venn diagram, there would be 3 different circles. Sorry, I should have gone to the board to do this, but for A, B, and C, 3 separate circles because they cannot, if one happens, the other one can't. So number 1, it says A and C are independent. That cannot be true because if one happens, the other one's probability goes to 0 if they're mutually exclusive. Mutually exclusive events are not independent events. They cannot be both mutually exclusive and independent. Independent events, if you had those, they always have overlap. If one happens, the other one still can occur. They have to have overlap. So this one right away throws that out. Well, that's good because we can throw out A, we can throw out B, we can throw out C, we can throw out E. The answer must be D because as soon as we throw out 1, we're good. Well, it says probability of A and B is 0. That'd be true because A and B have no overlap. Probability of B or C would equal those 2 added together, and that would also be true. Mutually exclusive, you can simply add those together. Okay, so now this question, it was numbered 36 on some AP test. An experiment has 3 mutually exclusive outcomes, A, B, and C. Probability, that's the same question. I thought it was a different one, so apparently I got the same question on there. We're not going to do the same one twice. All right, so let's jump to number 2. Now, these are old free response questions on probability, and not going to probably have enough room to do these on here, so I apologize. I'm going to try to squeeze it in. I'll probably go to the board and talk about them. But airlines routinely overbook flights because they expect a certain number of no-shows. An airline runs at 5 p.m. commuter flight from Washington, D.C. to New York on a plane that holds 38 passengers. Past experience shows that If 41 tickets are sold, then the probability distribution for who actually shows up is on the table below, 36, 37, all the way to 41. Assume 41 tickets are sold for the flight. So part A, they sell 41 tickets, so that means we're meeting this probability. This one is called a discrete distribution. Only certain outcomes can happen. It's not continuous. The normal curve, if you remember the normal curve, that is a continuous curve because any outcome in there can happen. You can have like halves and things, but this has exactly integer amounts. And these probabilities, if you add them up, they add up to 1 or 100%. Okay, so A, 41 tickets are sold. There are 38 passenger seats on the flight. What's the probability that all passengers who show up for the flight will get a seat? Okay, so part A, I'm going to do it up here. Part A, probability that all get a seat. Right. So what are we actually talking about? Well, we would have to have, that would be the same if there's 38 seats, then 36 could show up, 37 could show up, 38 could show up, but we can't have any of these. So none of those can occur in that scenario. So one way we can do it is we could say it's 38 or less. And we're simply going to add those together. We're going to add the 46, the 30, and the 16. And if you get something as basic as this on the AP exam, make sure you show this basic probability work. That will count as your work. That's 76 should be 92%. Now these happen to add up to 8%. So you could have shown your work as 1 minus that 8%, got the same amount. But with 39, 40, and 41, somebody's going to get bumped. Next, part B, what's the expected number of no-shows on this flight? This one I want to spend a little more time on. We're going to erase this normal curve that I don't need, so I'll do part B up here. Again, apologize for the room, but this one, the expected value is the same as the average. So on your formula sheet, you have something like this. Oh, I keep putting a P instead of a mean symbol. The mean is the sum of xi times pi. Okay, so we did this one a lot where you take 36 times its probability plus 37 times its probability plus 38 times its probability, so on and so forth, all the way up to 41 times its probability. Now, my suggestion is that you do that one in your list and spreadsheet view. So you may not have a TI, but if you do have the TI Inspire like I have, if you don't, you just have basic lists. I'm going to call them X. I'll call it X and F, and there's a reason for that, but we'll talk about that in a moment. 36, 37, 38, 39, 40, 41, and 36. Oh, sorry, I was not thinking there. We got 46, 30, and 16, so you put the frequency in here. That's why I called it F. And then we got 5, 2, and 1. Okay, now you do one variable statistics. If you're using the 84, on here we're going to go menu 611, one variable statistics. You still say one list. The data is actually only in the list X, but you have to put the frequency list as F. If you're using the TI-84, you got to make sure you go list 1, list 2 as the frequency. If you don't put that frequency in, it's not going to be correct. So our mean is the X bar. It should be 36.9. If you get that question on the AP test, should be pretty easy, but you have to be familiar with that formula. You don't have to show this formula. If you actually showed that formula and then went equals 36.9, that would count as the work, or you can show some of the work. You don't have to do both. Let's see, given that not all passenger seats are filled on a flight, what is the probability? Only 36 showed up for the flight. Okay, so that's a given probability. So on the formula sheet, we do have this thing, probability of A given B, and that equals the probability of A and B over the probability of whatever the given was. Okay, so this one, it's given that not all are filled. So they're not all filled. That would indicate that it's either 36 or 37 have showed up. So our bottom probability is 76% because we either are here or here, not all filled. But if 38 show up, it can't be 38, it can't be 39, it can't be 40, it can't be 41 because all the seats would be filled. So it's given they're not. What's the probability that 36 show up? So this has to be both A and B. It has to be both 36 and not filled, which the only one for that is the 36. So we take the 46 divided by the 76 on that. And I don't know what I just did there, but we get 60.5% for that one. That's a given probability. I do believe everybody should be able to do a given probability on that, so hopefully you remember that and are reviewing that. Let's come down to number 2. A simple random sample of adults living in a suburb of large city was selected. The age and annual income are given. Let's jump to part A. What's the probability a person chosen at random from these in the sample will be in the 31 to 35 age group? So that's saying out of the total probability, they're in 31 to 45. So this is basic probability, remember. So we're going out of the 207, and then the 31 to 45 age group is 89 people. If you get something as simple as that, make sure you show the work. The 89 out of the 207 should be pretty easy for an AP Stat student to get that one. And we get 43%. Now, a lot of times they don't say what to round to. So I recommend just 2 decimals usually. If it says, then you'll have to round to that. B, what is the probability a person chosen at random from those in this sample whose incomes are over 50,000 will be in the 31 to 35? Now, this is an A given B question. So it says whose incomes are over 50,000. So that's giving us the given. So the over 50K group, that's what we're drawing out of. So we want to go in here, and we only want to select our answers from this group. So the bottom number is out of the 96. And then they have to be in the 31 to 45 age range, which is 35 of them. May want to practice some of those, read some of those slowly. These are actual old AP test questions, so this one we'd get 36% chance. Based on your answers to A and B, is annual income independent? Now, there's a rule. If the probability of A given B, which we calculated right away, which was 43, if it equals the probability of A, which we found that one to be 36, they're independent. So 43 doesn't equal 36. In other words, the probability of 31 to 45 changes if in the 50K category. So they're not independent or dependent. Okay, a little bit of review with the independent-dependent situation. Number 5, an advertising agency. I'm just going to jump straight to question A. If an adult is to be selected from this sample, what's the probability the adult is a college graduate or obtains news from the internet? Okay, so this one, college graduate, would be this group. Or gets info from the internet. Internet would be this group. So it's the 687 and the 693, but the problem is we have some overlap, 245. You don't want to count those two twice. So we take the 687 and the 693. And we subtract 245. And we'll divide by 2,500. Sorry for typing in front of you. And we get 0.454. We did several of these. You can kind of see the Venn diagram here. The whole idea of a Venn diagram is A is this whole circle. So if we had like 0.3, 0.2, and 0.1, we say what's the probability of A or B? That would be the probability of A, which is 50%. That's this whole circle, plus the probability of B, which is 30%, which is this whole circle or oval. But you have to subtract the overlap. So you get 0.6. It's only those three added together. If you were to take the 41, the 401, the 245, add those up, and then add these without adding the 245 again, you should get that 1,300 or 1,135 that we got there. All right, B. If an adult who is a college graduate is to be selected at random from this sample, what's the probability that the selected adult obtains news primarily from the internet? I'm going to take this, and I think, sometimes drawing on this is helpful. I would bring a pencil. You should be using a pencil on the AP exam. But if you have things like this, when you're drawing on them, it's a little bit helpful. So adult who is a college graduate is to be selected from the sample. Okay, so we know we've got one of these. It's given they're a college graduate. That was supposed to be a C. I'm going to leave it. So we're drawing out the 693. What's the probability they obtain information from the internet? That's the 245. So 35% chance that happens. All right, part C, last one. When selecting an adult at random from the sample of 2,500 adults, are the events is a college graduate and obtains news primarily from the internet, independent. Okay, now this one didn't lead us quite the same as the last one, but whenever you do an A given B problem, compare it to just A. So we just did probability of internet given college graduate. So let's find the probability of just getting info off the internet alone. We haven't done that yet. Probability of internet alone is 687 out of 2,500. Now, if that value is the same as this, if it's 35%, then they're independent. And we get 19%. So the probability, I got to be careful not to hit that stop sharing button, probability of internet given college graduate does not equal the probability of internet because 35 doesn't equal 19.6. So no, they are dependent. Now this is one of those things, some students really get this, some students struggle on it. So remember, study the things you know for the AP exam. If you understand that or believe you can get that and remember that stuff, then put a little time into it. Make sure you understand independent, dependent. Remember, independent, mutually exclusive, not the same. Get what you can out of this. If you're like, this is a weakness for me, I wouldn't spend hours studying this again. It's not worth it for the one or two problems you're going to get right. I think people who have this as a strength, you can study it, make sure you got it down. Study the things you know to give yourself the best chance to remember the things you're really good at on the AP exam, and then let the other parts come as they may. You can just, if it's a multiple choice question, you come with not sure, try to eliminate questions and then take your best guess at that point. Okay, so we'll end there for today. That's some basic probability. Do more of that this weekend.